Now, find in radians the measure of the angle of the sector. Okay? So the angle of the sector is this. We have an angle, and then we have the sector here. Dan. Okay? Now what happens is the arc length is I don't know, I'll do this one here, number 2. The arc length is 9, the radius is 6. L equals r theta. Theta therefore is L over r, which is 9 over 6, which is 3 over 2. The angle is 3 over 2. Okay?
3 pi over 2?
No, nothing to do with pi. Pi only accounts when it's 180 degrees. It doesn't have to be in terms of pi. Okay, guys?
But it's all radians.
It's already in radians. The radians definition is that formula. You divide your arc length by your radius. So the last one, for instance, will be 24 divided by 10.
That's all you have to do.
Which is 24 divided by 10, which is 2.4. That is all you gotta do. That's what I did yesterday, if you look at the video. Okay. Alright, guys, moving on. Number 35. P, Q, and R. P, Q, and R are points on the circle. The radius of the circle measures 3 centimeters. The angle PQR equals 60 degrees. Find the minor arc QR. Okay. There's a rule from junior cert that is when this is 60 degrees, the arc underneath it has to be double that angle to 120 degrees. Okay? So then 120 degrees, L equals R theta. R equals 3. Okay? So what this is going to be is we got to convert 120 degrees into radians. So what we do is we divide it by 180. Okay? And this turns it into pi radians because 180 is pi. So what we're going to get is 2 over 3 pi multiplied by the radius, that is 3. 3 divided by 2 over 3 equals... Oh, sorry. Yeah, it's 2 pi centimeters. Okay? That's that one done there. Now, the windscreen wiper clears a flat region PQRS of a truck windscreen. PQ and SR are circular arcs at center O. OR is 20. RQ is 60. Sorry, that's RQ. Oh yeah, RQ is 60, okay? And POQ is 2.2 radians. Calculate the region of PQRS. What I'm going to do first and foremost is I'm going to do a red region, which is here. The red region is a half R squared theta. It's going to be a half. Now it says RQ is 60, but also says OR is 20. This means that the radius I'm looking to use here is 80 squared. Multiplied by 2.2. Can somebody do that on the calculator for me very quickly? Sorry, was it?
7040.
Okay, 7040. Thank you very much. Okay, and that's centimeters squared. Now, guys, over this side, okay, the small. If we were to rub this out, and what I'm going to look for next is this little region in here, the blue region in here. Sorry, blue. And what this is once again it's an arc, and it's going to be a half R squared. It's going to be 20 squared times theta, which is 2.2 radians. We're going to put that into the calculator, and what do we get?
440.
440. Sorry, just 440?
Yeah.
Okay, take them away from each other. 6,600 centimeters squared, right? 37. Alright, who got that out? Okay, so somebody's got it out, alright? Now, guys, is that the last one you want me to do today? 37?
Yeah. Finish up.
Okay. Sorry? Okay. So what we have here is the following. We have an area of a shape of a sector. Okay. A piece of wire 40 meters in length is bent in the shape of a sector of area 100 centimeters squared. The length of the radius is shape of a sector of area 100 centimeters squared. Oh, it's a sector, so that means that's it basically. I know. We did half of it. Okay, guys. So what happens is it's going to be r 40 minus 2r, because you got to take away the two radiuses from 40. Now, what you're going to do next is you want to show that theta equals 40 divided by 2r over r. L equals r theta. Theta therefore equals L over r. Theta therefore is 40 minus 2r all over r. Find the value of r. The only other piece of information we have is the area. Area equals a half r squared theta. A half r squared theta is 40 minus 2r all over r, and all of that equals 100. The r on the outside, r on the inside cancels with that r on the outside. Multiply both sides by 2, turns that to 200, gets rid of the half. Then we're left with 40 multiplied by r is 40r. R multiplied by minus 2r is minus 2r squared, and that equals 200. Bring everything over the right hand side. 2r squared minus 40r plus 200 equals 0. Divide everything by 2. R squared minus 20r plus 100 equals 0. What we're going to get here is r, what was it?
The senior tennis team.
Okay. It's grand. Okay, guys. Minus 10 and minus 10. Okay. Now that it's minus 10 and minus, I mean the radius equals 10. Now remember, it can't be a negative number, so that equals 10. So r equals 10 is the answer to that question, right? And then because we know it equals 10, what it wants to find out is the value of theta. Well, theta therefore is going to be 40 minus 2 times r, which is 20. 20 divided by r, which is 10. Theta therefore equals 2 radians. Okay? Continuing on. 42. Now, a sector of radius r subtends an angle of 1 radian at its centre. The length of the arcs is L. Write down the equation involving L and R. Well guys, the truth is, when you have, remember what a radian is. 1 radian is, radians are how many times does your radius length fit into your arc length. Okay, so once again, imagine I had something like this. I had, this is 1 centimetre and this is 3 centimetres. How many radians is that angle there? 3. So it's very much just about dividing your arc length by your. So basically guys, what happens here is L equals r theta, but we know that L equals r. Theta equals L over r, and that's going to be the same as r over r, which is 1. It's 1 radian. Okay? Read the second question really closely. The diagram shows 2 concentric sectors. I think that basically means there's 2 sectors in the same sector. Okay? COD is 1 radian. The radius of the smaller sector is r, and the arc CD is 2 centimeters longer than the arc AB. The shaded region ABDC has an area of 10. Calculate the value of r. I'm not going to go through it all, but here's the basic gist of it, okay? This is r. Let this be called L. This one therefore must be L plus 2 centimeters longer. Now look at this. It's 1 radian. So remember what I said, angle equals L over r. That means that 1 equals, oh sorry, I'll use the same formula. L equals r theta. This means that L equals r. So what I can now replace this with is, I can replace this with r. Now why did I replace it with r and not r with L? Because if you read the question, it wants r on its own, not l. So that's going to be r over 2 and r. Now here's the next problem. Okay? The other one, this is the smaller sector. I'm now going to draw the bigger sector. The bigger sector can be here. But once again, the angle is 1. And when the angle is 1 radian, it means that the arc length must equal the radius. So now you know the radius of the bigger one is r plus 2. Okay, so now that we have that cleared, what it wants us to do is it's take away the area of the big sector minus the small sector. So the area of the big sector, it's a half, the general formula is a half r squared theta. It's going to be a half, now the bigger one is r plus 2. A half r plus 2 squared times 1 minus, what's this area of the small sector? A half r squared 1, and all of that has to equal 10. Solve that equation. You guys can do it. Just multiply by 2, get rid of the half, square it out, quadratic formula. You'll be doing it in a second. Okay guys, number 43. Now to do number 43 has a bit of a trick to it, okay? What I'd like you to do is this. Change the diameter into 200 centimeters. Therefore the radius is 100 centimeters. Draw the center of the circle. Link the center of the circle to the other 2 points. Draw this straight down. Then what I'd like you to do next is this here is the radius. This makes this side 100. What do we know about the red length? It has to be what?
60.
Where'd you get the 60 from? Okay. So now that we know that's 60, you're going to do Pythagoras' theorem to figure out what this is. Do you understand?
Yeah.
Then double the answer to find out the length across. Then you're stuck with, how do I find out the area of the shaded part? Well, it's very easy. It's the area of a triangle. And how do you get the area of a triangle? Half base by height. So whatever your base is by your height, and then whatever that answer is, take it away from the area. Now guys, we know that it's going to be a radius of 100. Shh. How do you find out, Dan? How do you find out what this angle here is? I have the hypotenuse and the adjacent. So we call it A, angle A. Cos of angle A equals 60 over cos inverse it, find out the angle and double it because it's both angles. See the way it's, we found out that one, but we want to double it, change it to radians, and then once you change it to radians, you're going to use a half r squared theta.
Is that the log?
A half r squared theta? Yes. Now guys, remember to find A, you're using cos inverse 60 over 100. Okay, I'm going to come back to that. Now, number 44. Interesting one as well. Okay guys, number 44. The diagram shows a sector P of circle 0 and radius 6. AB and AC are tangents. What does tangents mean? It touches it, which means that's 90 degrees, and this here is 90 degrees. Okay, the angle BOC is 2 theta. Okay, now there's a rule about this. Okay, the rule is if I join this one to this one here, it cuts that angle in half. So therefore this is going to be angle theta, and this one here is also angle theta. Perfect. Okay, write down the area of the sector P in terms of theta. So what's it going to be? It's going to be a half r squared theta, which is going to be, what's r? 6. It's going to be a half 6 squared theta, which is, what's it? 18 theta? Oh, sorry guys, it's not theta, it's 2 theta. Why is it 2 theta? It's the full angle. Okay, which is 36 theta. Okay, find the area of the triangle OAB. Now, OAB is the top triangle. It's going to be the same size as the bottom triangle. So to find the area of the height of a triangle, you need to do a half base by height. Now guys, we know that this here is 6. And it says in terms of tan theta. This is 6. What is the opposite side then? If that's theta, opposite and adjacent. How do you relate opposite and adjacent to each other? Tan theta equals opposite, or we'll call it the length x now, x over 6. X therefore is 6 tan theta. And then what you're going to do is you're going to get a half base by height, which is a half 6 times 6 tan theta, which is going to be 18 tan theta. Okay guys, I'm going to leave the last 2 parts up to yourselves. We'll get them tomorrow. Now finally, 47. Looks hard, but it's not. Okay guys. Now, when you have a cone, okay, should have it here. Okay guys, so when you fold this upwards, okay, what's going to happen is this here is the same thing as this one. There, they're the same size, because when you actually fold up the shape of a cone, that's going to be the slant height and the real height. And it goes right down the value of L. L is 20. It goes, show that R is 10 root 2. Use Pythagoras' theorem. If that's 20, it says the height equals the radius. They're equal. That means that can be R and that one can be R. Do Pythagoras' theorem, you'll end up getting R squared plus R squared equals 20 squared. 2R squared equals 400. R squared equals 200. And then R is going to be equal to 10 root 2. Now that you know that R equals 10 root 2, then your last job is to show that the angle theta equals root 2 pi. Now, yeah, okay. So what we'll have to do is, to find the angle, you got to get from here to here. Okay. Then once you do that, you're going to. Alright, just stop there. I'll get the rest of that tomorrow. For your homework tonight, guys,